Yes. Well, hello. We are Erick Salgado, Samuel Betancourt, Santiago Camacho, and Santiago Contreras, and we're going to talk about using genetic algorithms in test data generation, which is a critical systematic mapping. All right, we are going to go ahead.
So first of all, we have the abstract, in which I'm gonna say that software testing is one of the most expensive phases of development. It often requires a lot of time and resources, especially when done manually. Genetic algorithms, or GAS, can automate test data generation. They help reduce effort and costs by generating effective test inputs automatically. This study reviews research on the use of GIS for software testing. It highlights common approaches used in the field, recent trends in the research, gaps where further investigation is needed. GIS are especially helpful in early development stages. Using them early can prevent expensive bugs later in the process. So in this chart, compares the cost and time of manual testing versus testing automated with generate algorithms or GAS as shown. GAS can significantly reduce effort and resources, making them ideal for early development stages to prevent costly bugs.
So the introduction. Exhaustive software validation is often not feasible. Testing every possible input combination is complex and time consuming. GAs are inspired by biological evolution. They use evolutionary techniques such as selection, which is picking the best solution, crossover with what is combining solutions, mutation, introducing random changes. They explore large input spaces, and this helps to improve the code coverage and fault detection, which is some finding more bugs and try the best version of the code. Now in this flowchart illustrates how generic algorithms work. They start with an initial population of test inputs, evaluate them, and select the best one. Apply crossover and mutation, and repeat the cycle. This evolutionary process help generate better and more effective test data automatically.
Right. Well, now with the results. Well, most studies focus on structural or white box testing. What does it mean? You may ask to yourself. Well, this means testing is done with knowledge of the source code, aiming to cover all internal paths. Common GA techniques include designing fitness functions to target specific paths or bugs, using random or heuristic-based initial populations. We have also representing data as binary, numeric, or domain-specific formats. Also, some research uses hybrid models. GAs are combined with neural networks or symbolic programming to enhance performance. We have some reported benefits, up to 40% improvement in code coverage compared to the traditional methods. However, only a few studies compare GAs with traditional methods in terms of execution time. Now, about the chart. This bar chart shows how much code coverage improves when using genetic algorithms compared to traditional methods. Some studies report up to 40% better coverage, as I said before, meaning more parts of the code are tested and more bugs are detected.
Finally, in the conclusions, we have that GIS work well with simple data types, for example, integers or short things. Struggles arise with complex inputs like images, 3D objects, or nested data structures. We can conclude that this kind of investigation can focus in the future can focus on scalability to complex systems, computational efficiency, integration into CD pipe pipelines, real world and critical system testing. And in the last one, the biggest change is design good fitness functions. These functions decide how good a test, test case is, and designing them is still difficult.
Well, here
Uh,
is the biography, bibliography. So you can maybe search, I don't know, so you can get more into the topics or that topic. And that would be pretty much it. Thank you for paying attention.